Hi everyone. So today we'll be discussing on the topic offline dynamic connectivity. So this is one of the important algorithms. Yeah. Let's discuss the same. So offline dynamic connectivity is a technique to answer the connectivity queries. Basically, it is used to answer the connectivity queries in a graph where edges are added and removed. So these two operations you have to remember. So we'll be going with the edges as well as the removal, adding edges as well as the removing edges. Yeah. So it is used to answer the connectivity queries in a graph where edges are added and removed by processing all the operations offline, known as this one beforehand. So it uses divide and conquer plus DSU, right? So usually we'll be going with the segment tree as well as the divide and conquer and the DSU with the rollback to effectively simulate the dynamic changes. Yeah. Always remember the pure dynamic, this one, what do we call? The pure offline dynamic connectivity always consists of the segment tree, divide and conquer, as well as the DSU with the rollback. Yep. So divide and conquer is a technique, whereas it consists of the data structures, segment tree, as well as the this one algorithm, DSU basically. Yeah, DSU with the rollback actually. Yep. So this is fine. So we'll be implementing the DSU with the rollback within this itself. So the next algorithm also will be discussing on the DSU with rollback itself. Now we'll be having the complete idea before we hop into the DSU with a rollback algorithm. Yeah, let's do one thing. Now we have the idea, right? So we went through the definition part of the offline dynamic connectivity. Let's do one thing now. Let's discuss the approach. Yeah, then we can just articulate the same thing that we will be discussing in the approach in the form of code later. If everything goes well and if we get the desired output, then we can just what we can do, yeah, then we can just discuss the complexities for the code that we have written. First, as usual, let's discuss the approach. Yep, let's do that. Let's do one thing. Let's move on with the further things. Yep, just give me a second here. 1 second. So let's start discussing about the this one algorithm. Yeah, these are the example operations that we have went with actually. So we'll be adding the edge, this particular edge 1, 2, and then we will be adding the edge 2, 3. So then we'll be querying 1, 3. So we have the edge 1, 2, and 2, 3. Then we can query entirely, right, for the 1, 3. Yep. Then we'll be removing the edge 2, 3, nothing but the second one. Then finally, after removing the edge, again we'll be querying 1, 3. So this is the example that we'll be going with. Yeah. So this is the graph actually, initially graph 1, 2, 3, 4, 5. So you can clearly see here what we'll be doing basically. What is the core idea? So instead of handling dynamically, what we'll do, we'll track the time intervals when edge is active, right? When that particular edge that we have added is active, we will track the particular time. Yep, that we'll be doing. Now we will build a segment tree over time, right? So I'll just write here build. We'll build a segment tree over time. First, what we'll do, we'll track the time intervals when the edge is active, particular edge is active. Then we'll build the segment tree over time. After building the segment tree, we will assign the edges to the segments. We'll assign the edges to the segments where they exist, right? Traverse tree, then we will traverse the tree and apply the DSU unions. Then we will what we'll do, then we'll traverse the tree and apply the DSU unions, then roll back after returning, right? So then we'll go with the rollback after returning. Now this is fine. Let's move on with the key insights. What we'll do, we'll simulate the edge exists in the internal interval. Sorry, we'll be simulating whether the edge exists in the interval, not step by step updates, as we'll be making use of the this one, what do we call segment tree, as well as the DSU. We can easily simulate whether this one edge exists in the interval or not, right? So that particular part we can just easily simulate. Now, so we don't have to go with a step-by-step updates, right? So this is fine. First, this is the time actually. Yeah, this is the time. 1, 2, 3, 4, 5 is the time, and this is the segment tree, and this is the segment tree. Suppose this is the simple example actually that I've considered. 1, 5 is nothing but the range actually, range or the edge you can consider, right? Edge range basically. 1, 5, 1, 3, 4, 5, 1, 2, 3, 4, 5. Yep. So here, so this is nothing but the we are considering the active intervals of the particular edge. First, what we are doing, we are adding the edge, this one 2 comma 3, 1 comma 2, and 2 comma 3, right? So here 1 comma 2 we already have. So edge 2 comma 3 is active from 2 comma 3. So this one edge 2 comma 3 is active from 2 comma 3. So it goes into the segment 2 to 2 and segment 3 to 3. Yep, 2 to 2 as well as the segment 3 to 3. So this is for the edge active interval. Actually, you will get to know when we write the code. Yep. So this is the segment tree. This is the segment tree, and edge 2 comma 3 will be active from 2 comma 3. So this one. So it goes into the segment 2 comma 2 and 3 comma 3. So this one 2 exists in this one 2 comma 2 range actually, and 3 exists in the range to 3 comma 3. So quite obviously it goes into the segment 2 comma 2, 2 to 2 as well as the 3 to 3. So that's what I have mentioned. So this is the time we have considered, and for that particular time that we have considered, I have mentioned the segment 3. It's as simple as that, right? So I had already mentioned that we'll simulate edge exists in the edge existing in the interval, not the step-by-step updates. So that is the reason I have mentioned like this, the graph along with the segment tree. This is nothing but the edge active interval. Yeah, don't get confused. So this is it for the this one. What do we call algorithm part? Yeah, let's see the same thing in the action. Let's try to articulate the same thing in the form of code. Yep, by making use of the Java programming language. Let's do that quickly. Let's move on with the further things here. The first thing here, we will be making use of the buffer writer and the print writer. So I'll just import input output package as well as the utility package. We'll be making use of the different utilities as well. So I'll just go with imported stuff. So we have successfully imported the this one utility as well as the input output package. 1 second. Yeah. Let's move on with the further things. Now within the class actually, what do we call offline dynamic this one connectivity class. First thing, let's go with the DSU with the rollback support. Yeah, as per the algorithm that we discussed actually. Yep. So I'll just go with class here, DSU. So within this particular method or within this particular class, first thing we'll be having parent as well as the size. So I'll just go with the parent and size for the union actually. You would have already guessed actually. Yep. So this is fine. 1 second. Yeah. Let me remove this. Yeah. Next, let me go with a stack. Yeah. Let me go with a stack of integer. So this one is not the integer actually. It will be int. So this is fine. I'll just go with history. Yep. Let me go with a history. So this is fine. Next, let's move on with the constructor part. So this will be DSU of int n. So this is fine. So within that, I'll just go with the parent. Yep. So let me assign this one to new int of size n. Yep. Also size, let's consider size. This will be same. New int of size n, and for the history as well. Yep. So for the history, we'll be going with a stack. So next, let's move on with a for loop. For loop because we have to make sure that each node is its own parent initially, and each component size is one initially. So these two things we have to make sure. So we'll be writing the for loop. Yeah. So let me write this one. So I'll just go with within the for loop. Let me assign parent of I, and also size of I. Let me assign this one to 1. Yeah. So we are done with the this one DSU class. Next, let's move on with the this one. What do we call DSU? We have to go with the find as well as the union, right? Within the find, we'll be going with the this one path compression, and with the union will be usually within the union will be usually going with a this one union by size or union by rank. Usually we call it as union by rank. Yeah. So first let's go with the path compression or the find method. So I'll just go with the int find. So let me take one parameter here named x. So I'll just go with while loop here, while x not equal to parent of x, and also in that case, let me do one thing. I'll just assign x to parent of x. But I've already guessed this one. We have implemented DSU this one number of times by now actually. Yeah. Too many times we have implemented this one DSU as well as DSU with the rollback as well. So we should be knowing the DSU algorithm by now. Yep. So this is fine. Let's move on with the further things. I'll just go with size of size actually. All we have to do is we have to return x, nothing but the parent. Yep. So this is fine. Now let's move on with the parent part. Yep. Not the parent part, union part. Sorry. So I'll just go with int. Not int actually. It has to be void. So I'll just go with a union here. So let me go with two parameters. One is a and another one is b. So within this method, union method, so let me assign a to. So this one will be find of a, and also let me assign this one b to find of b. Yep, so this is fine. Next, let's go with a simple if condition here. If A equals B, then let me do one thing. I'll just go with a history dot push here, dot push of new int. So instead of A and B, so let me do one thing. I'll just go with a -1. Yeah, 3 times -1. So this is fine. Let me come out of this one entirely. We have to stop here. So I'll just make use of the return statement. Yep. So this is fine. We are done with this part. Next, so if they are already connected, if the edges are already connected, we have to store the dummy state for the rollback consistency. That's what we have done here. So A equals find of A. If you know the algorithm, we are just finding the root of A as well as we are finding the root of B. Now, after this step, let me do one thing. I'll just come out of this one entirely. Yeah. So now we have to go with union by size. Nothing but we have to attach the smaller tree under the bigger one. Right. So I'll just go with if let me go with size of A if it is smaller than the size of B, not greater. Go with a smaller than symbol. Yep, it's smaller than the size of B. In that case, what we have to do, we have to consider the temporary variable. I'll just go with temp of A equals B equals temp. So this is fine. Yep. So next, let's do one thing. I'll just come out of this one entirely. Now we have to store the previous state for the rollback. For that, we have made use of the history variable. I'll just go with a history dot push. Again, new int of. So this time it will be B. Yeah. And let's go with the parent of B. Yep. And also one more thing. Let's go with this one. What do we call? What we have to go with? Size of A. Yeah. So let me go with the size of A. So this is it for the this one, storing the previous state part actually. Yep, for the rollback utility. So I'll just format the code. Yep. Now let's do one thing. Let's move on with the further things. So just give me a second here. One thing. So let's attach B under A. Right. This is pure DSU actually. So this will be parent of B. Let me assign this one to A, and size of A here equals size of A plus size of B. Yep. So this is it for the this one union method. Now, as we are going with the DSU with the rollback, we have to go with the rollback method as well. So I'll just come out of this one entirely. Now, let me do one thing. I'll just go with rollback method. Yeah, let me go with the rollback method here. So within the rollback method, first thing, we have to get the last change. When I say we have to get the last change, I'll just go with int. Let me go with the last equals history dot push actually dot or I'll just go with a pop. Yeah. So this is fine. So if last of 0, if there is dummy operation, then we have then we do not have to do anything. In that case, I'll just go with if last of 0 not equal to -1. Actually, if it is equivalent to -1, we have to consider, right? So if dummy operation, then we do not have to do anything. We just have to stop actually. For stopping, I'll just make use of the return statement or the return keyword. Now we just have to go with the node whose parent has just changed actually. For that, let me go with int b equals last of 0. Yep. Then we have to consider the previous parent, nothing but for that I'll be going with a variable old parent, and let me assign this one with the last of this one sorry 1. And for the old parent, so let me change this one to capital P. So this is fine. And I'll just go with the old size. Yeah, this one, old size. So let me assign this one to the last of 2. So this is also fine. It's as simple as that. Now we have to consider the current parent. So I'll just go with int A equals parent of B. Yep. So this is also fine. Now we have to restore the old parent as well as we have to restore the old size. For restoring the old parent, so let's go with the parent of B equals instead of A, let me go with old parent. Yeah, let me go with the old parent, and also size of A, this one here, let me go with the size of A equals old size. Yep. So I'll just this one format the code so that the code looks good. Now we are done with the this one. What do we call rollback method? Yeah. So next, let's move on with the main thing. Nothing but we have to add the edge, right? So we have to add the edge, and we will be going with the DFS as well. So I'll just explain this one step by step. First, Before adding the edge, let's do one thing. We need the segment tree where each node stores list of edges, right? So I had shown you the segment tree, why we will be making use of the segment tree. And also we have to go with all the three operations, add, remove, as well as the query. Yep. So for that, let me make use of certain variables here. Static. Yeah. So let me go with the list here. So this one will be list of int. Let me go with a segment. Yeah. So this is fine. And let me go with a static here. So this is fine. I'll just go with the list of string. Yep. Let me go with the list of string. I'll just go with the queries. Yeah. So this is fine. So next what we'll be doing, so these are nothing but add, remove, as well as the query operations. So now let's go with a method to add the edge to the segment tree in the interval. Nothing but query left as well as the query right. If you know the segment tree, this one, you know what I'm speaking of. Yeah. If you don't know the segment tree itself, it is present in the this one 150 based algorithms playlist, and also it is present in the tree based algorithms. Yeah. So you can just check that this one video and you can just come back here if you don't know the segment tree concept actually. Yep. So now this is fine. Let's move on with the further things. I'll just go with a add edge method here. Void add edge. So let's consider certain parameters here. Node, I need node. So this is going to be left. This is going to be right. This one will be query left, and this one will be query right. Let me go with the edge u or the vertex u as well as the vertex this one b to connect the edge basically. Yep. So within this particular method, first thing what we'll be doing uh, to add the edge, first we'll be checking query right. If it is less than left in that case, or right, this one less than query left, in that case we do not have to do anything. All we have to do is we have to stop. So I'll just go with a return keyword, so when there is no overlap. Yeah. So this is pure segment tree. We have to store the edges in the segment. So for storing the edges in the segment, I'll just write one more condition here. If query left, if it is less than or equal to left, and suppose right is less than or equal to query this one, right? Then in that case, I'll just go with a segment of node. Yep. Dot add of, I'll just go with new int. So this is fine. New int. So let me go with here. This one. Vertex u as well as the v. Yep. So let me give semicolon or we'll be getting the error. So this is fine. Now we have to stop. So I'll just make use of the return. So I'll just give a return keyword here, right? So let me come out of the if condition entirely. Now let's divide the segment. For dividing the segment, I'll just go with mid equals. So this one will be left plus right by 2. Yeah, so this is fine. After dividing the segment, let's go with the left as well as the right child. For the left child, I'll just go with the add edge. So this one will be node into 2. I'll just go with the left. I'll just go with the mid. Let me go with the query left. Let me go with the query right. So this is also fine. I'll just go with the vertex u as well as the vertex v. Yep. So let's do the same thing for the right. A bit different because we'll be this one will be considering from the mid to right. For the left, we will be going with a left to mid. For the right one, we'll be considering from the mid, nothing but mid plus 1 to right. So that's how we consider within the segment tree, right? So I'll just go with add edge again. So this time, let me go with node into 2 plus 1. This is a correct actually. Instead of the left, so we don't need this one over here. Instead of the left, let's go with the mid. Yeah, we have to go with the mid plus 1. We have to move to the next one, right? So for that, it will be mid plus 1. Then let me go with the right actually, right? Then query left and query right is we need that one. We need both query left and query right. Then u and v are the vertex. Yeah. So this is it for the right child actually. We are done with the add edge method completely. Now let's go with the DFS traversal of the segment tree. Yep. So I'll just go with the static here. So I'll just go with void DFS. So I need certain parameters to perform DFS. One is I need node, I need left, I need right as well, and another one is DSU. Yeah. So let me go with the DSU. So this is fine. So within the DFS method, first thing, we have to count how many unions we do in the particular segment. For that, let's keep one variable named changes here. And let me initialize that variable with a value 0. Now we have to apply all the edges stored in this particular segment. So I'll just go with for loop here. So this one is int e of this one. We are considering from the nodes that are present in the segments, actually segment of node. Yep. So within the for loop, first thing, let's go with a union operation. That is the reason we have written this one union operation, right? So I'll just go with a dsu dot union here. Union of, we need to pass initial this one e of 0 comma e of 1. Yep. So this is fine. Next, let me go with a, let me increment the changes. When I say let's increment the changes meaning here we have to track the changes for the rollback. Yeah. So after tracking the this one changes for the rollback, let's write one more condition here. Suppose if the leaf node is equivalent to the single query, right? For that, let's write the simple if condition. See here, this is one of the important edge cases as well. If L equals R, in that case, so suppose if leaf node is equivalent to this one single query, then I can just write it in this way, string. So let me consider the variable parts here. Yep. So this is fine. Let me go with the queries. Yeah. Dot get of, for the left, I'll just go with the variable L. I'll just make use of the split here. Split. Yep. So this is also fine. Yeah. So next, let's go with a simple if condition here. If parts of 0, yep, if parts of 0 dot equals, yeah, if parts of 0 dot equals of query then what we'll do, within the if condition, let's go with the node u as well as the node v. So I'll just go with u equals, let me go with integer dot let me go with a %. Yep. So this is also fine. Let me go with a parts 1. Yep. So same thing, let's do for the vertex v as well. So I'll just consider here this one, instead of v, let me change, instead of u, let me change this one to the v, and this remains same, integer dot %. Instead of the parts of 1, we have to consider 2, right? So this is the only change that is required. Now let's move on with the further things. We have to check if both the nodes have same root. Yep. So so if it is connected, then let's print yes. If it is not connected, then let's print no. Let's do that. Let's check if both nodes have same root. So I'll just go with if here. We have written find method for that, right? So if find of u actually, so I'll just go with the find of u equals, again instead of v, I'll just go with dsu of this one, not size actually. It will be find of. I'll just go with the v this time. Yeah. So in that case, what we have to do, as I've said, if it is connected, then we have to print yes, or let's print yes. So I'll just go with yes within the strings. Else, let's print no. Yep. So I'll just go with else system out println. So let me give no here, right? So this is fine. Yep. Yeah, we are done with this part. So let's do one thing. Next, let's go with the else. So within the else method, sorry. So let's go with the mid calculation first. Yeah, I'll just go with mid equals. So segmentor is the binary tree, right? So I'll just go with L plus R basically by 2. So this is fine. Then let's go with a, we have to go left and we have to go right. For that, we have, let's recurse actually. DFS of node into 2, L mid as well as the DSU. These are the parameters that will be considering. Next, if we want to go right, then let's recurse node into 2 plus 1. So this is correct. Then mid plus 1, R as well as the DSU. So this is also correct. So this is fine. Now let me come out of this one entirely. All we have to do is we have to roll back all the changes done in the particular segment or in this segment that we are considering. For that, I'll just go with a while loop here. While changes, so this one hyphen if it is greater than 0, in that case what we'll do, so I'll just go with a dsu dot rollback. Yep. So this is fine. Let me format the code so that the code looks good. Now let me come out of this one entirely. So this is it for the algo, right? So this is it for the algo. whatever the example that we will be considering, basically that we will be doing within the main method. Usually I take that one from the Google. Usually I take the example part from the Google. Let me do that. And before that, let me tell you what are the things that this algorithm uses mainly offline dynamic connectivity. We are making use of the DSU with the this one, what do we call rollback actually, from here to this part, from the first line of the code that we have written to line number 73. Then it uses the segment query, segment tree as well, right? For adding the edge, and we have to add edge and we have to remove edge, right? And we have to consider the edge within the segments, yeah, within the particular segments. For that, we have went with a segment tree. Yeah, we have already discussed that one. So from that is from line number 75 up to this one actually. Where? Yeah, up to line number 124. Now, this is it for the algorithm. As I've said, we will be going with a DSU rollback. This is the divide and conquer method, basically. You can just check the code. It's pure divide and conquer. And this one, basically the data structure segment tree as well. Yep, pure segment tree, DSU with the rollback, and this one, what do we call? Divide and conquer. All the algorithms, basically, whatever I have mentioned, all the algorithms we have already discussed, right? So we have discussed a DSU algorithm within the that is present in the 150 this one algorithms playlist. DSU with the rollback, mm, not DSU with the rollback, basically DSU algorithm. Then this one, what do we call? Mm, DSU as well as the segment tree. Segment tree algorithm is also present actually. Then this one, divide and conquer method also we have discussed actually. That's the approach basically we have discussed in the form of algo by considering the example. You can check that one, all the three algorithms. Now, as I've said, within the main method, we'll be considering the simple example and we'll be writing the code that is related to the input output operations. Let me take that one from the Google. Just give me a second. So let's do one thing. I'll just paste it over here. So this one, so this is purely related to the input output part and the example. So first thing, let me explain you this one step by step. Yeah. So n we have considered 5 and q we have considered 5 here, right? N is nothing but the number of nodes and the number of operations that we are going with here is nothing but q. We have assigned this one to the 5. Next, we are going with a this one, what do we call? We have to save the query somewhere, so we are making use of the array list. So this is fine. And we this is nothing but the storing operations actually. Query dot add. We have considered the same example actually. If you remember, uh, while explaining the algorithm, or yeah, while discussing the algorithm part, I have went with, or we have went with the same example. You can just check the part where we discussed the algorithm, where we have discussed the algorithm. We have went with the same example. We have added 1, 2 as well as the 2, 3 edge, and we are adding the query 1, 3. We are querying 1, 3, and we are adding we are removing the edge or 2, 3, as well as we are querying 1, 3 again, right? So this is fine. Next segment, so this is nothing but the segment tree size basically. Yeah, this is nothing but the segment tree size. We don't have to worry about it that much. And then we are just going with a hash map, because we have to store the edge as well as the start time. As I've said, so we will not, while discussing the algorithm, so we will be maintaining the this one, what do we call, the edges, and the we need edges as well as the start time, rather than the traditional method. Yeah, rather than the traditional array processing method. So we will be going with the segment tree, and we will be considering the edge as well as the its time actually. Yep, its start time actually. Yep. So then we have to process the queries to build the intervals. For that, I have written the for loop. Yep. So until here basically, until here, right? So this is fine. We have to store the start time. So we have made use of the map output basically to update the time. Yep. So we have to update the time, right? Or we have to store the start time. For that, we have made use of the map output here. And one more thing, within the else if we have made use of the start equals. So we are assigning this one to the map get of key. Nothing but we are getting the start time. If you know the get operation, this one, whatever the hash map provides actually, usually we'll be able to get the value, right? So here we are trying to get the start time actually. That we went with the hash map. Within the hash map, we went with the edge as well as the start time. We are trying to get the start time by making use of the get operation that is provided by the hash map. That's what we are doing. Now map dot remove of key, what it does, we are just removing from the map actually. Based on the key, we are removing the value or the time actually. Yep, that's what we are doing. Next, we are going with the add edge method. We have already written this one, add edge method. So what it does basically, so we get the edges that are active from the start to I-1 with the help of add edge method. That is the reason we have written add edge method. Actually, we have made use of the segment tree for that. Yep. So this is fine. Now let's move on with the further things. So here, uh, so there are certain edges that are active till the end. Yep. So basically the edges that are never removed at all. That one we are mentioning here, right? So this is fine, I believe. Finally, we are going with the DSU. DSU nothing but we are initializing the DSU for the this one. What do we call? Uh, basically Yep. We went with a union by rank, right? Union by size, basically. The operations within the DSU actually, path compression as well as the union by size. So we are calling the DSU here, nothing but we are initializing the DSU. And finally, we are processing the segment tree. Yep. For that, uh, we had we have written the or we had written the DFS method. We are calling the DFS method and we are calling the parameters, right? So accordingly with the parameters, we are just going with the value 1, 0 until q minus 1 as well as the this one. We are calling the DSU based on the DSU, right? So that is the reason we have written the DSU basically, right? We are making use of it within the DFS method. Yep. So this is it for the algo. Yep. So this is it for the algo. Let's do one thing. I'll just come here. Let me run the code. Yeah. If everything goes well, we have to get the desired output. So we are getting yes and no, which is absolutely correct. Yep. 1 second. So basically what is happening here, let me explain you this one. Just give me a second here. Where did it go? Yep. See here. So we are going with a query 1 comma 3 actually. We are just querying 1 comma 3 here. So we are querying 1 comma 3 at the time 3. At the time 3, so we have to get the yes here because uh, accordingly with the segment tree that I had shown you actually 1, 2 and 3 are connected. So this is the range actually. Accordingly with the in the segment tree words actually we have mentioned the range 1 to 3 and we are checking whether 1 to 3 is connected. So I can just check the segment tree that we had discussed actually. That part of the video you can just go and check where I had shown you the segment tree actually. 1, 2 and 3 are connected. So here we have to get the output this one. Yes actually. Yep. Yes. Next query again, we are going with a 1, 3 at the time 5. At the time 5. So I had shown you the time 1, 2, 3, 4, 5, right? So we are again querying 1, comma 3 at the time 5. So this one, the input that we have considered or the example that we have considered, right? So we are again querying 1, 3 at the time 5. So no edge. So here in this case, we have to get the output no because edge 2 and 3 previously we have removed. Yeah. So edge 2 and 3 we have previously removed. You can just check the input that we have given. Edge 2 and 3 we have already removed. So in this case, we have to get the output no. So S and no is the output that we need to get. Yeah. For this we have got no. For this we have got S. So S and no is the output that we need to get, and we have got the desired output here. S and no accordingly with the query that we have considered, accordingly with the input that we have considered. Within the input, add edge as well as the query we have considered. So add edge, remove edge as well as the query. These three things we have considered. So accordingly with the example that we have considered, we have to get the output yes and no, which we are getting. And we are getting the desired output here in this case. Yeah. Now, I hope the concept of this one, what do we call? Offline dynamic connectivity is completely clear. Basically, it uses, what does it use? It uses this one DSU with a rollback. Yeah, DSU with a rollback, divide and conquer, as well as the segmentary data structure. Yep. So these three things we have to know at any cost. Now let's do one thing. We are done with this part, right? So I'll just minimize this one. Yeah, let's do one thing. Yep. Let's try to implement the offline dynamic connectivity in the algorithm. Sorry, in the problem, right? So let's try to this one implement the same algorithm. Yeah. So yeah, let's do that. So let's move on with the problem part actually. Just give me a second, 1 second. Yeah. So this is fine. Let's move on with the problem part. So we'll be solving this particular problem, or we'll try to implement the algorithm, whatever we had discussed actually, offline dynamic, this one. Connectivity algorithm, yeah, that we will be applying within this particular problem, dynamic graph vertex add component sum. This is one of the best problems or the finest problem to implement this one offline dynamic connectivity algorithm. Yep, through the this one DSU rollback segment tree as well as the divide and conquer method. Yep, we'll be seeing this one in the action. Let's try to implement the same thing. First, let's try to understand the question. Yeah, let's do that. Just give me a second, 1 second here. So yeah, what does the question state here? Yeah, what does the question state here? You can just go through the question. It's very easy to understand. Time limit, they have strictly mentioned 10 seconds. Yeah, so I'll just summarize the question so that we understand the question even better. It will be helpful in solving the problem actually. Yep, first thing, we have a dynamic graph with n nodes. Yeah, first of all, we are having dynamic graph with the n nodes. Yeah, just remember this one, and no initial edges, and no initial edges. Yep, so this is fine, I believe. Again, we have a dynamic graph with n nodes and no initial edges. Yep, so each node has a value. Again, each node has a value. Yep, and edges can be added or removed over time, and edges can be added or removed over time actually. Yep, so we also update nodes dynamically. So whatever the nodes that we consider in the input, so we update this one dynamically. Just remember this one, they have strictly mentioned in the question. We also update the nodes dynamically. For a query, we must return the sum of values in the connected component of a node. All we have to return is whatever the query. In the input, we will be given the query. Suppose it is one of three. So we have to return, or but yeah, we must return the sum of the values in the connected component. The sum of values in the connected component. So let me write it here clearly. Query is given actually. We have to, all we have to do is we have to return the sum of connected component. Yeah, sum of the values in the connected component. So this is what we have to return basically. Yep, of a node. So that's what they have given in the question. It's as simple as that. Now, let me read the question out loudly. Just listen to this carefully. So we have been given a dynamic graph. Yeah. So we have been given a dynamic graph with a n nodes and no initial edges. So we are not given any edges initially. So we are just given the dynamic graph with the n nodes. First thing. Yep. So each node has a value. Each node is having the value and edges can be added or removed. Yeah. So edges can be added or removed. So why we cannot make use of the DSU? We have to go with the DSU with the rollback. That's the reason actually. Delete operation cannot be performed with the help of the DSU, right? So delete this one operation can be performed with the DSU with the rollback. Yep, as we are making use of the this one DSU with the rollback, this point is extremely important. Again, I'm saying this, stressing on this. We are not just going with the DSU. We are going with the DSU with the rollback because DSU operation we cannot perform delete operation within the this one traditional DSU. So we are going with a DSU with a rollback. Just remember this one. Yeah, it's very important while implementing the while implementing certain things. You have to know certain things why we are implementing these things and all, right? So this is fine. Now again, each node has a value. Edges can be added or removed over time. We also update node values dynamically. Yep, we also update the node values dynamically. That's fine. And for a query, we must return the sum of values. For the query, what we have to do, we must return the this one, sum of the values. So this one. Yeah, before that one, we have to update the nodes dynamically. That is also one of the thing. We also update the node values dynamically. For a query, we must return the sum of values in the connected component of the node. In the connected component of the node. It's as simple as that. Yep. Now we have complete idea on the question. What we need to output actually. What are the things that are given? Initially, we are just given the dynamic graph with the nodes. The edges are not given. We should be able to this one add and remove the this one edges. Yeah. So one thing, we should be able to add the this one, update the nodes dynamically, and we should be able to return the sum of the values in the connected component of the node. Yep. So let me delete this one. The question is simple. Now they have given the time limit 10 seconds. We can just write the code. This one, we have been given the sufficient time actually. Yep. So this is fine. As I've said, we will be going with the this one. We'll be implementing pure this one offline dynamic connectivity algorithm here by making use of the segment tree and all segment tree data structure, and also two things, divide and conquer as per the algorithm, offline dynamic connectivity algorithm. And also one more thing, we will be going with the DSU with the rollback. And again, that I have mentioned, or I had stressed this one earlier, DSU with the rollback, because we cannot perform the this one delete operation with the traditional within the traditional DSU by considering the traditional DSU. So that is the reason we'll be going with the DSU with the rollback. Yep. So this is fine, I believe. Next, let's move on with the this one approach part. So after discussing the approach, let's try to articulate the same thing in the form of code. If everything goes well and if we get the desired output, then we can discuss the complexities for the code that we have written. First, as usual, let's discuss the approach. Yeah, let's do that. So let's continue with the approach part. So here, what's the key idea? We cannot make use of the normal DSU. We have already discussed this one. We cannot make use of the normal DSU because edges are remote. DSU doesn't support the deletion, as I had stressed this one earlier. So I mentioned this one here as well. Just keep this one in mind. So we can just make use of the DSU with the rollback. Along with it, we have to go with the segment tree on time. So accordingly with the algorithm, so we had went with the segment tree on time as well. Within the algorithm, I had shown you the same thing actually. Yep. So we'll be going with the segment tree on time, nothing but offline processing. Yep, nothing but offline processing. That is the reason we call it as offline dynamic this one connectivity. Yep. So we'll be making use of the DSU with the rollback, and we'll be going with a segment tree on time, and it's also known as for the online processing. Basically, that's the reason we call it as offline dynamic connectivity. Now let's move on with the core strategy or the core idea. First, what we'll do, so this one is just for the brush up sake. So we had discussed the same thing within the algorithm as well. First, what we'll be doing, we'll be tracking the edge active intervals. First, we have to track edge active intervals. Yep. So the one, the edges that are active until the end actually. First, we'll track edge active intervals. Then we'll build the segment tree over time. Then we'll build the segment tree over time. So this is accordingly with the algorithm. We have discussed this one within the algorithm itself. Then we will be building the segment tree over time. So the third step is nothing but we have to store the edges in the time ranges. I had shown you in the algorithm by this one. With the help of the segment tree, we had built the segment tree. I had shown you that one. So we will be storing the edges in the time ranges. I had shown you the time range as well, 1 2 3 4 5, if you remember that one in the algorithm. Yeah, and later I had shown you the segment tree as well. That's what we'll be doing here as well. The same thing, exact same thing will be this one implementing here, right? So we'll be storing the edges in the time range, whatever the time range that we are given in the input. We will be storing the edges in the time range. Then we'll this one will be going with the value updates in the time ranges, right? So we'll be going with the value updates in the time ranges, value updates that we have to do in the within the time range, accordingly with the time ranges within the time ranges. So in our case, we removed the h 2 to 3 that was in the range 2 2 as well as 3 3, if you remember. Yeah, within the algorithm. Yep, the same thing here. We'll be going with the edges in the time ranges, and we'll go with the value updates in the time ranges as well. Next step, or the last step, is nothing but we have to traverse the segment tree. Yep, as we are going with the segment tree for the offline processing, the this one algorithm actually it demands for the offline processing, and the offline processing we will be usually doing with the segment tree itself. That's the best thing, and it's extremely faster as well. Yep. So we'll be traversing via segment tree. What we'll do when I say we'll be this one traverse via segment tree or traverse segment tree, so we will be applying the edges, nothing but union. So the union that we will be going with a within the DSU actually. We'll be going with a find. Within the find, we'll be going with a path compression, and we'll be going with one more method within the DSU with a rollback actually. That's nothing but the union. That union will be making use of actually. We'll apply the edges. Basically, we'll be making use of the union. We'll apply the updates as well. Similar to the algorithm that we had discussed, there also we used to apply the updates. So here also we'll be applying the updates. Finally, after applying the updates, we have to answer the queries. So in the input, we will be giving will be given add edges, remove edges, as well as the this one answer queries. We have to answer the queries from 1 to 3. 1 to 3 itself we considered, I believe, within the algorithm actually. Yep. Like the same actually, they'll be in this particular problem also will be given the input in that format as well. Add edge, remove edge, as well as the remove nothing but the deletion, as well as the answer queries. Queries will be given as well. Yep, answer queries. And finally, we have to go with the rollback changes. The rollback changes because we will be making use of the we should be able to delete the edge actually, or remove edge. For that purpose itself, we are going with the DSU with the rollback actually. Finally, what we'll do, we'll roll back the changes, right? After doing everything, we'll roll back the changes by making use of the rollback method. We can just write the rollback method, one more method in the DSU along with the find as well as the union. We'll be writing one more method named rollback. It's as simple as that. Yep. If you know the DSU and if you know the segment tree, implementation is a piece of cake when it comes to offline dynamic connectivity. Offline dynamic connectivity algorithm involves segment tree for the offline processing. For that purpose, you have to know the segment tree at any cost. If you don't know the segment tree, you'll not understand anything. You have to blindly this one. What do we call? You have to just blindly write the code, or you have to just blindly this one. You have to go this one. Yeah, you will be implementing the things blindly actually without understanding anything. That is the reason I say that to go uh, just open the 150 algorithms playlist. You'll find the this one segment tree as well as the DSU algorithm actually. Yep. This DSU with the rollback is also present, I believe. If not present, we will be this one discussing next. DSU with the rollback algorithm. We'll be discussing that one next in detail. Yeah, that we will be doing. We don't have to worry about it for now. Yep, as I've said, please do go through the this one segment tree algorithm. You have to know that one. Yeah, segment tree is one of the special this one data structures actually. So you can just go through that one. We have discussed that one, and you can come back here, right? Divide and conquer also you have to know. Yeah, it's a technique actually. It's very simple. Divide and conquer is very simple. Divide and conquer, segment tree, as well as the what do we call a DSU with a rollback. These three concepts you have to know to this one to implement the same thing but on this particular algo. Now let's move on with the graph actually. Yep. So we are considering this one. Let me scroll over here. So you can clearly see here this input we are considering. We are having actually 5 inputs with the 16 edges. They have given here 5 inputs with the 16 edges. So we are going with the first input. Yeah, so we are going with the all 5 inputs here. So basically, sorry, um, right here, one, then we are querying 3 here. So yeah, we have to get 6 outputs actually. Yeah, 6 outputs, right? Accordingly, with the they have given the query as well here. You can clearly see. Yep. They have given 30 here. We need to query. So this is fine. Hmm. Yep. So let's consider the input actually. The input they have strictly mentioned here: 001, 012, 023, 034, as well as 004. This part I'm speaking of. Yeah. You can clearly see here. 1 second. 1 second. From here to here. 001, 012, 023, 034, as well as the 045. Yep. This part. Yep. So this is nothing but the input. We'll be considering the same thing within the approach part as well. Yep. So let me close this one. Yeah. Let me delete this one and close this one. Otherwise it will remain like this. Yep. So this is fine. Let me open this one. Yeah. Now we have the graph here. We have the graph. See, we have 0, 1, 2, 3, 4, actually 5 vertices. Yeah, that's what they have mentioned here. 5 vertices, nothing but the five, yeah, 5 vertex, yeah, 5 vertices and 16 they have given here. 5 vertices or the nodes is nothing but 0, 1, 2, 3, 4. Yeah, 0 to 4, they're connected. Yeah, all the nodes are connected or every node is connected here. So it forms a cycle and it is undirected graph. It is not the directed graph. So all the nodes are connected here. So it forms a cycle for the input they have mentioned. 001, nothing but 00 edge. This one 01, 02, and 03, 004. Actually, they have mentioned 00. So this is fine. Now, this forms a cycle accordingly with the graph that we have considered. It forms a cycle because all the nodes are connected. Yep. So this is fine, I believe. So the same example that we are considering that they have given in the question, the first input. Yep. So let's go with a step-by-step explanation. Initially, the values that we have, initial values they have mentioned here. See, 1, 10, 100, 1000, and they have mentioned here 10,000. These are the initial values that they have mentioned actually for this particular input until here. So this one is the first input that we have considered here, right? So just give me a second here, 1 second. Yeah. So this one, 516 initial values they have strictly mentioned here. These are nothing but the initial values. These are nothing but the edges that they have given here: 001, 012, 023, 034, 004, and we have to consider the initial values, right? Let's move on with the same actually. Yep. 1 second. What happened to this one? Yep. So the initial values are 1, 10, 100, 1000 as well as the 10,000. So when we sum up this one, we will get actually triple one, double one, nothing but 5 ones actually you can count. Yeah, you can count. So we get triple one, double one. Then we are asked to query from this one. Time range they have given, a range they have given actually here, nothing but the time range itself. 3 3 they have given for this particular input, right? So this one 3 3 they have given. Let's query 3 3. Let's query 3 3. So when we query 3 3, components of the node 3 we have to consider, as we are going with, as we are asked to go with this one query 3 3, component of the node 3, all the nodes. So the we have to consider all the nodes. Components of the node 3 are all the nodes. It forms a cycle, right? Graph. So we have to consider all the nodes. Output will be same thing. Triple one, double one, nothing but the 5 ones. Then we are asked to remove the edge 1 2. Yeah, then we are asked to remove the edge 1 2. Here you can clearly see this part. Then we are asked to remove the edge 1 2. So I'll do one thing. Then we are asked to remove the edge 1 2, right? So just give me a second here. Where is it? Yeah. So here graph becomes like this. We are disconnecting this part. We are disconnecting this part actually. Yep. As we are asked to remove 1 2, we are disconnecting this part. We have moved from 0 to 1, then 2 to 3, 3 to 4. Still it forms a cycle. Every edge is connected 0 to 4. By looking at the graph itself, you can say 1 to 2 is disconnected. Still it is connected via cycle 0 to 4. You can clearly see the graph. I insist you to pause the video and have a look into it. Still it is connected via cycle. So all the nodes are still connected. Yep, all the nodes are still connected. So this is fine. Now let's move on with a query 3 1. Yep, so we have been given query 3 1 here after removing the edge 1 2. So we have to query 3 1. They have strictly mentioned here to query the 3 1. Yep. So now the output for the query 3 1 within the segment tree, we have to go from the this one range 3 as well as the 1. So it remains same again. So it will be triple one, double one, nothing but the 5 ones again. Yep. Next, we are asked to remove 3 4. Along with the 1, if we are given something, nothing but this is removal. Along with the 1, if we are given the edge, nothing but it is removal or the deletion here 1 3 4. So we have to this one remove 3 4. Yep, we have to remove 3 4 here. We have to remove the edge 3 4. So we have already removed this one 1 2. So we will be removing edge 3 4 as well. Edge 3 4 as well. Accordingly, with what they have given in the input, we will be removing the edge 3 4 as well. Yep. So we have successfully removed 1 2. We have successfully removed 3 4 as well. Now, yep. So now the components, nothing but 0 1 4 2 3. We will check whether it is still connected. It is still connected via cycle. So I have connected this one to the 2. Sorry. So this one has to be actually. So let me connect this one to the 4. So I have to connect this one to the 4 actually. Anyways, now this is fine, I believe. So we have so this one I had connected wrong actually. So this forms a cycle. This is still connected to this one via 0 to 4 cycle. Yep, not 0 to 2 basically. It's connected via cycle 0 to 4. Yep. We will check 0 1 4 2 3. Is it still connected? It is connected via 0 to 4 cycle. You can clearly see here. You can clearly see here, right? So just 1 second. Yeah, you can clearly see here. Look at the graph actually. I insist you to pause the video and have a look into it. Now the graph is still connected. Yep, we are having the cycle and graph is still connected. Next in the input, we are asked to query 3 0. Yep, within the segment tree, this one we have to consider 3 3 as well as the 0 0. Yeah, time actually basically we have to query 3 0. So now the values of all, meaning, so we have to consider 1 plus 10 plus 100 plus 1000. So that's the values that they have given. So now it will be 1 followed by this one 4 zeros. So this one, what do we call? 1 followed by 4 zeros and the values that they have given in the question, right? So it will be 10,000 plus this one, what do we call? 1 second. So this is fine. Now after this operation actually, whatever we have done here, so this will be triple one, double one. Yep. So triple one, double one, we get the same value actually. Yep. So this is fine. Now we have been given the update actually. And one more thing, let me mention this one if you don't know. So I have mentioned this one already. So 0 in the sense we have to add it, nothing but AE. I'll write add it here. 1 if they have given something with a 1, then it is nothing but the removal or the deletion. Yep, removal or the deletion. If they have mentioned something with the 2, actually it is nothing but we have to update actually. Yeah, we have to update. Yeah, so just remember this one. Yep, just remember, if they have directly given 3130 something like that, it is nothing but we have to query. It is nothing but we have to query. So this is it. This is it for the uh, so this one you have to remember. Sorry. Yep, this one you have to remember. Yep, don't get confused here. Yeah. So next step we have to move on with the this one 2 1 10 this one, not 10,000 actually. They have mentioned here 1 lakh. It is 1 lakh actually. 6 zeros we have, right? 6 zeros or 5 zeros. 1 second. 5 zeros actually. Yeah, 1 lakh itself. 10,000 will be having the 4 zeros, right? So this is fine. Next we have to update to one this one followed by the value that they have given, nothing but 1 lakh here. So values of all is nothing but we will be going with 10 this one hyphen 10010. Yep, 10010, right? So here this will be 11111 the value plus this value. So again this would lead to 11111. The final value would lead to 11111. You can just check actually. Yeah, that I'll just leave it to you. You can just check. Yep. So this is fine. Now let's move on with a query 3.1. Let's move on with a query 3.1. The next one, we have been given query. So we have to query 3.1. For querying 3.1, we have already done that one. Yeah, we have already done that one. The value is similar to the for the similar. Yeah, the value will be similar as per the previous value. It would be 111 and 111 respectively. Yep. So next, we are asked to go with a this one. We have to add the edge as they have given this one in the form 014 actually. Yep. So we have to successfully yeah, we should be able to add the edge successfully. Now we will check whether the graph is connected. The graph is still connected, man. So this graph is still connected actually via 0 to 4 actually. Via 0 to 4 the graph is still connected, and I have mentioned here graph still connected. Next we are asked to go with a query this one query 3.2. For the querying 3.2 we have already discussed this one multiple times. This is nothing but it gives us the solution 110011. Yep, 110011. So after some removals earlier, the component got changed. The component got changed actually. Yeah, after some removals earlier, the component got changed. So the final value that we got for querying actually for everything that we had queried. So I can just check here. Query 3.3. What we got here? 11111. For the first value we have got here 11111. So this is fine. Then for next querying actually after 11111. So for next query, 1 second. Yeah, again we got 11111, right? So we'll be going with 11111 again. For the third one, we have got here 1 second. Query 3.0 actually. Again we got this time we got actually we have to update, right? So we got 10011, then 110 110011. So for this one actually for querying 3.2, then we got 1100 and 11111. So accordingly with the input that we have considered here, the output that I have written, so I can just check for the queries and the input they have mentioned actually adding the edge and removal of the edge after all the this one after all the operations that we have done. So the output will be this one. 11111 for the first one, the second one also 11111. Sorry, 11111 for the first and second. 10011 for the this one third one. 111011 for the fourth one. 1100 for the fifth one, as well as 11111 for the sixth one. So this is it for the final query. So I hope this is clear, right? This is completely clear. All we have to know is we have to add the edge. We have to check whether the graph is still connected, and we have to perform the removal of the edge operation, and we have to query in the place that they have given. So the final output will be this one accordingly with what we have discussed actually. Now let's do one thing. We have completely discussed the this one, what do we call approach. Yeah, we have completely discussed the approach. Let's move on with the or let's try to articulate the same thing in the form of code. Let's try to write the code Same thing, similar to the algorithm, we'll be making use of the segment tree, DSU with the rollback, as well as the divide and conquer method. These two things. So we'll be going with a pure implementation of the offline dynamic connectivity. So let's see that one in the action. Let's try to implement the same thing in the form of code. Let's do that. Yeah. Let's move on with the this one. What do we call coding part? So we'll be going with a pure implementation, right? So let me close the algo part. So I'll just go with this one, the problem name that I've given here. So the problem will be huge as we need to implement this one segment tree as well as the DSU with a rollback and the divide and conquer and other stuff. Optimization is required according to the constraints that they've given. So let's go with a step by step. Let's go step by step. So I'll just go with import here java dot input output dot star. So this is related to the input output, and let me go with import java dot util dot star. So this is for the we have imported the we'll be making use of the different utilities. So I have imported utility package here. So next, let's do one thing. First step, let's go with a data structure. So I'll just go with a class edge here, or graph also you can say. I'll just go with a edge. So within the edge, first thing, we have to store the endpoints of the edge. We need two vertex. One is u and another one is v, as we will be considering the edge actually. So this is fine. So let me go with the edge here. Two vertex int u as well as the int v, as we need to connect the vertex as edge actually. Yeah. So I'll just go with this dot u equals u, and also let me go with this dot v equals v. So this is fine. So this is just the constructor that initializes the edge. Next, let's come out of this one completely. Now within the edge class, so we will be going with a add class as well. So I'll just go with let me do one thing. 1 second. So we have to come out of this one entirely, right? So I'll just come out of this class entirely. Yeah. Now let me go with the static class. So I'll just go with the add here. So yep. So within the add method, first let me go with a variable node here. Node nothing but it is the node index. Next, let me go with the delta. So delta is nothing but the value to add. And the next one, let's go with a constructor part. So I'll just go with the same thing, same variable naming actually. I'll just go with a int node as well as the long delta. So within the constructor, let me assign the node to the node, as well as I'll just go with delta to the delta. Yep. So this is fine, I believe. Next, what we'll be doing, I'll just come out of this one entirely. Let me format the code here. Yeah. Let me format the code. Next, let's move on with the further things. Let's move on with a record method. So I'll just go with static here. I'll just go with class record. So within the record class, sorry, not the method actually, within the record class, first thing, let's go with the type. So 0 is union and 1 is add. We need to go with the type actually. Yep. So for that, I'll just consider the variable type. Then we need the DSU nodes that are affected. For that, I'll just go with child root. Yeah. I'll just go with the child root, as well as let me go with the parent root here. Right. So this is fine. Let me change this one to capital R. So for here as well, for the child root. Let me come out of this one entirely. Now we need the previous size before union. For that, let me go with the previous size. Yep. So this is also fine. Still didn't get changed. Okay. Finally, we need the previous sum before the operation as well. For that, I'll just go with the previous sum. Now let's do one thing. Let's move on with the constructor part. So I'll just go with the record. So here I just need type, which is of the type this one int. Then I'll just go with the child root here. Yep. So this is also fine. Let me go with the parent root as well. So this is also fine. And let me go with the previous size. Yeah. So this is also fine. And let me go with the previous sum. Yeah. So this is fine. Within this this one constructor part, first thing we have to store the type. For that, I'll just go with this dot type. Yeah. So this dot type, let me assign this one to type. Yeah. So this is fine. The next one, so I'll just go with the child root. Yeah, we have assigned this one to the child root. So this is also fine. Next, let me go with the parent root. Let me assign this one to the parent root. Next, will be go with the going with the previous size, let me assign this one to the previous size, and next let's assign this one previous sum to the previous sum. Yep. So we are storing the type, we are storing the child root, we are storing the parent root, we are storing the previous size, and we are storing the previous sum as well. Yep. So within the constructor part, let me come out of this one entirely now. Next, what we have to do, so let's consider some global variables that will be helpful for us in the future. First, let me go with the number of nodes as well as the queries. For that, I'll just go with a static int n as well as the q actually. Yeah. So this is fine, n as well as the q. Next, let's go with the query types. I'll just go with a static int. This one will be type. Yeah. This one will be type. And static int. So here type is enough, man. Wait, did I hit tab here? Anyways, so let's move on with the further things. So we need one more thing. I'll just go with a static int here. So this time I just need two variables, a and sorry, what happened here? A and b respectively. Why we are going with the a and b? So we need the query parameters, right? For that query parameters, I'm going with the variables a and b. Next, we need values for type 2 queries. So I'll just go with static here. So this one will be long. So let me go with the X. So this is fine. Next, let's consider the segment tree storing edges. For that, I'll just go with the segment edges or SEG edges. I'll just go with static here. So let's make use of the array list for this. Yep. So I'll just give edge here, right? So we have to mention the array. So I'll just go with a segment edges or SEG edges. So this is fine. This is the variable name I'll be going with. And also, let's go with a segment tree storing the updates. We have to go with the update as well. Update operation, they have strictly mentioned in the input. We have to update as well, right? For that, let's go with a variable segment adds, right? Adding basically update. If there is any changes needed, we have to update, right? So I'll just go with static here. So this one will be array list. Yep. So let me go with a variable add. Yep. So let me give segment adds actually. Yep. So this is fine. Next, what I'll be doing. So I'll just go with the DSU parent array and the size array. So let me go with static here. So this one will be int. So let me go with the parent as well as size. So this is fine. Next, we have to store the sum of each connected component. For that, I'll just go with the static. So this one will be long. Yeah. So I'll just go with a sum. Yep. So this is fine. After successfully storing after successfully considering the variable for storing the sum of each connected component, let's go for the stack actually. Yep. Stack for the rollback. Stack for the rollback. Yeah, we need that one as one. We need that one as well, right? So I'll just do one thing. Let me go with the static here. I'll just go with the array list. Array list. Yeah, this time let's consider the record. Instead of we don't need here this one. What do we call array? So instead, I'll just go with a variable name history. Yeah. So I'll just go with a new array list. Let me complete the syntax. Now I'll just go with a static. So this is completely fine. Let me go with a long. Yep. I'll just go with a answer. Yep. We go with the answer. So this answers for type 3 queries actually. Yep. So this is fine. Yeah. Next, let's move on with the DSU with the rollback. Right. So DSU with the rollback. I'll just go with static. So let me go with void here. I'll just go with init DSU. This is nothing but the initialization, right? So let me go with parent here. Parent, let me assign this one to new int of size n. So this is fine. I'll just go with the size. Let me assign this one to again new int of size n. So this is also fine. Let's consider component sum. So again, new long of, as we went with the long, it was showing this one suggestions. It was showing in the suggestion. So this is fine. Next, we have to we know this from this one algorithm that each node is its own parent, and initial size and initial sum we have to set. Initial size will be setting this one to 1. Initial sum will set this one to the 0 by making use of the for loop. If you know this one, what do we call DSU algorithm? So we'll be going in this way usually, right? So I'll just go with int I equals 0, I less than n. So let me increment the I. So this is fine. Within the for loop, let me go with the parent of I. Let me set this one to the I. Size of I, let me set this one to the 1. And third one, comp sum, component sum of I. Let me set this one to, or let me initialize this one with a 0. So let me format the code now. This, why does it look like this? So yeah, I have not mentioned what do we call parenthesis over here. That is the reason I'm showing that. We don't need any parameters. Yeah, so this is fine. Let me format the code now. Yeah, so that the code looks good. Let me come out of this method entirely. Now, DSU, if you know the DSU, we have to go with the path compression as well as the union. Let me type this one quickly. I'll just go with the static and find. So this is fine. Parameter X. So I'll just go with a while loop here. So the exact same thing we had implemented in the algorithm as well. Yep. So let's write this one quickly. I'll just go with a parent of X. If it is not equal to X, then let me set the X to the parent of X. Yep. So next, let me do one thing. All we have to do is we have to return X. So this is fine. We are done with this particular method. Next, let's move on with the union method, pure DSU, right? So I'll just go with a void here, union. So we are just going with the parameters. So usually we go with the U and V, right? So let me consider U and V itself. You can go with the X and Y, any variable. So it has become an this one habit actually to make use of the U and V. So this is fine. I'll just go with a RU. So here this one will be find of U actually. Yep. Why it is find of U here? We are what we are doing here, we are going with the root of U, and next we have to go with the root of V actually. Entire V, I'll just go with a find of V. So this is fine. So if already in the same component, then we have to stop. For that, let me write the simple if condition. If, so I'll just go with RU equals so we have to check RU equals RV, right? So it's not just RU, it's RV, right? So this is fine. Then the next step would be so we have to go with the union by size. So this one will be if size of RU, if it is less than size of RV, in that case what we have to do. So let's go with a swapping. So I'll just for the swapping I'll just consider the this one. What do we call? Temporary variable. I'll just go with the RU here. RU equals RV. So this is fine. RV finally we have assigned this one to the temp. Right. So let me come out of this one entirely. I mean if condition entirely. Now we have to save the state before the union. Right. If you know the DSU algorithm. So I'll just go with a history dot add. So because we have to roll back later, right? So I'll just go with a record here. So let me go with 0, RU, RV, or we have to go in this format actually, or else we'll be getting the error. RV, then RU actually. Then let me go with the size of RU and then comp sum of RU. So this one, let me change this one to the component sum, right? So within the, we have to write this one within the array itself. So I'll just mention RU. Right, so this is fine, I believe. Let me, yeah. I have already mentioned the semicolon, right? So this is fine. Next, what we'll be doing, we have to attach the smaller tree to the bigger, if you know the DSU algorithm. So I'll just go with the RV. So let me assign this one to the RU. Then we have to update the size. For updating the size, it will be RU actually. We have to mention RU. Right. So this is fine. RU equals size of RV, not RU here. Right. So this is fine. Finally, we have to update the sum. For updating the sum, we have went with a component sum, right? So I'll just go with a comp sum here of RU, not again, it's not RV, it's R, right? Equals comp sum of RU, right? Component sum of RV we have to go with, right? So we have to go with the component sum of RV. So this is fine. So this is it for the what do we call union method. We are done with the union method as well. Next, let's do one thing before going with the rollback. So as we are going with the DSU with the rollback, before going with the rollback method, let's go with the add value. We should be able to add the value as well. So I'll just go with the static here, void add value. So this is fine, not void, it's void. Yeah. So within this add value, so I'll just go with the parameter node, and let me go with the parameter delta. So within the add value method, first thing I'll just go with the root here. Root equals find of node. Yep, find of node. So this is fine. Yep. After finding the root of the after finding root of node, then we have to store the previous sum as well. Again, I'll just go with a history here. History dot add new record. So this one, let me change the value. Type, let me set this one to the 1. For the add, we are going with a 1, I believe. We are not going with a 0 actually. Yeah. Let's go with a 1. For the root, we have mentioned as root itself. And for this, I'll change this one to the -1 initially. Nothing but for the parent root actually. Let me set this one to the -1. And size of the root also, initially, let me set this one to the -1. And component sum, let's go with the component sum of root itself, right? So we are just storing the previous sum here, right? So we are just storing the previous sum here. So after this method, so let's update the component sum. I'll just go with the component sum of root equals the same thing plus delta. Yep. So this is absolutely correct. Now we are done with this method. Now let's move on with the rollback method. Yeah. So we'll be done with the DSU part actually if we write the rollback successfully. Yep. So I'll just go with a static void. So let me go with the rollback. I'll just go with rollback. So this is fine. I'll just go with one parameter. I'll just go with checkpoint here, right? Checkpoint. So here within this rollback method, first thing, let me go with a while loop. While history, while I'll just go with a history dot size, yeah, dot size. If it is greater than checkpoint, actually, if it is greater than checkpoint, then within the while loop, first thing I'll just go with a record here, a record R equals history dot remove. So remove history dot size -1, which is absolutely correct. Let me leave space here so that it looks good. Yep. So this is fine. Let me format the code once and let's move on with the further things. Now we have to undo the union. For undoing union, I'll just go with a simple if condition here. So yep, if r dot type, suppose if it is equivalent to the 0, then let's do one thing within the if condition. Let's restore the parent. For restoring the parent, I'll just go with the parent of r dot children. We have considered child root. Yeah, sorry, child root actually. Yep. So let me assign this one to the r dot child root itself. Yep. So this is fine, I believe. Next step, again, we have to restore the size as well. For restoring the size, I'll just go with a size of r dot. So this one is not this one previous size. I'll just go with a parent root here. So this one will be r dot previous sum, right? So this is previous sum actually. Yep. So this is fine. After restoring the sum, sorry, we have to go with the size itself for this, not the this one. What do we call sum? R dot previous size is fine. For the component sum, we have to consider this one sum actually. I'll just go with the component sum here. Right. So this will be r dot parent root. Yep. Again, yeah. Let me go with the. We don't have to consider the same thing again. So let me assign this one to the r dot previous sum this time. Yep. So this is it. Next, let's write the else. Else, what we have to do? We have to undo add. We have to undo add because we have to restore the sum. For that, I'll just go with the comp sum here. So this one is nothing but r dot child root. Yep. So let me assign this one to the r dot previous sum. So this is fine, I believe. Yep. So let me come out of this one entirely. Now let me format the code one so that the code looks good. Yep. So this is fine. Now we are done with the DSU part completely. Yeah. We are done with the DSU part completely. So next, let's go with the divide and conquer as well as the this one. What do we call segment tree? Actually, we have to go with the offline processing. For that, as I've said, we'll be going with the segment tree. Let's move on with the segment tree part. So let me go with static here, void. So let me go with add edge. So this is fine. Yep. So let me make this one small a initially. So we are going with a camel case actually. Add edge. So let me go with certain parameters. So let me go with int index. So I'll just go with the left here. Let me go with the right as parameter, nothing but r. Let me go with the query left as we are making use of the segment tree. I'll just go with query right as well. Yep. So if you know the segment tree, you'll be knowing this one. So I'll just go with the edge e. Right. So let me go with the edge here e. Right. So this is fine. What I'll do, let's move on with the further things. Suppose if there is no overlap, similarly to the code that similar to the code that we had written on the this one algorithm, the segment tree implementation will be doing the same thing here as well, exact same thing. So if you know the segment tree, how to make use of the segment tree, actually it will be very easy. Yeah, let's do that. Let's if suppose if there is no overlap, suppose query left is greater than or equal to r, or query right less than or equal to left, that then in that case we have to stop. So I'll just give the return. Next, let me go with a simple if condition. Suppose if query left is less than or equal to left, and I'll just go with right if it is less than or equal to query right. In that case, what we have to do, so we have to store the edge in the particular segment. So for that, we have made use of the segment edges, actually segment edges of index idx dot. So we have to add, right? So I'll just go with the add of what we have to do. We have to store the edge in the particular segment. So I'll just pass the e. Next, all we have to do is we have to stop. For that, let me give the return statement. Next, let's move on with the further things. So I'll just go with the mid here. So this one will be left plus right. So I'll just go with right shift 1. Yep, so this is fine. Next, let's move on with the left child as well as the right child. For left child, actually, let me go with add edge. So let me go with the add edge. So I'll just go with index here. Left shift 1, comma left, comma mid. So I'll just go with query left. Let me go with the query right as well, and let me go with the e. Right. So this is fine. I'll just go with the add. Sorry. Let me go with the add edge here. This one. So the same thing. Let's make some necessary changes as we're dealing with the right child. So this left shift operator remains same. Yeah, so this one remains same. I'll just go with a logical or one, nothing but we are going with a plus one. Yep. So this is fancy way of writing. You can just go with a normal way as well, right? So we will be going with a mid plus one, this one. Next index, we have to move from mid to right. We are considering. So segment tree is the binary tree. So the same thing. So usually, if you know the binary search, binary tree and all, the implementation of the segment tree will not be a big deal actually. So this is fancy way of writing by making use of the bitwise operators. That's it. Yeah, don't get confused. Anyways, so this is fine. And let me go with the mid plus one is not required for this. I'll just go with the mid. So instead of so this remains same. Right, we have given correctly. Query left, query right, as well as the edge. So this remains same. Let me format the code so that the code looks good. Now we are done with the add edge method. We are done with add edge method successfully, right? So now let's do one thing. So let's move on with the add update method. So I'll just go with the static here. So I'll just go with void. So let me go with add update. Yeah. So let's go with certain parameters here. I'll just go with the index. So let me go with the left. So let me go with the right as well. Let me go with the query left. Let me go with the query right. And I'll just go with the add a. Yep. So this is fine. Within the add update method, I'll just go with if query left. So yeah, if query left, suppose if it is greater than or equal to r, or this one query right, actually if it is less than or equal to left, then no overlap, the same condition that we have considered here, this one. Yep. So for that we have to stop, so when there is no overlap, right? So this is fine. Next, what we have written, if query left less than or equal to L and right less than or equal to query right, in that case what we have to do, again we have to store the updates actually. This time also we are will be doing the same thing, segment adds dot index add of a. Let me copy the same thing here, let me paste it over here. So this is fine. Yeah. Why this is showing error? Oh yeah, we have considered the variable a. We are updating, right? So we are not just adding, we are updating actually. So that is the reason we have considered this one a here. So I have given a. So this is fine. Next, after storing the update, all we have to do is we have to stop. So I'll just make use of the return keyword. So why this is screaming here? What it is saying? A required type edge provided add. Okay. So we have went with the add itself. Segment edges. Oh, this one here. Yeah, in a hurry, I went with that. This actually, I copied this one, I believe. So we have to go with the segment add. We are updating. We have to go with the SEG ads actually. Yep, so this is fine. Now the error should be gone. So I'll just come out of this one entirely. Sorry for that. So let's move on with the further thing. For the midpoint, we have to calculate the mid. If you know the segment is, so I'll just go with left plus right by 2, or again this is fancy way of writing by making use of the bitwise operator, the same thing, left plus right by 2. So this is fine. All we have to do is we have to go with the left child as well as the right child. For the left child, I'll just go with the add edge. Sorry, we are updating again. I'm forgetting this one. Yeah, add update. So this one, index left shift 1, so this is fine. Left, as we are dealing with the left child, so this is also fine. Mid is fine. Query left, query right, as well as A is fine. So this is fine. Next, for the right, we have to consider the right child as well. So here, add update. So this is fine. Index left shift 1, logical or 1. So this is fine. Then we have went with a mid. This is also fine. Then we have went with a right. Then we are going with the right. So this is also correct. Query left, query right, as well as the A parameters are correct. So this is fine actually. Yep. So we are done with the add update method as well. Yep. So now we are done with the segment tree part as well. So we are done with DSU with the rollback. We are done with this one, what do we call segment tree part as well. Now we are left with divide and conquer method. Yeah. So we will be going with the divide and conquer as well. Yep. So let's do one thing. Divide and conquer is nothing but in the algorithm we had made use of the DFS, right? So the same thing. That's nothing but the divide and conquer itself. If you know the DFS and divide and conquer, we have just implemented the same thing by making within the DFS method actually. So let me write that one quickly. Static. So I'll just go with void. Let me go with the DFS here. So I need 3 parameters, left and right I want. But along with it, I need index as well. Yep, I'll just go with the index. Let me go with left as well as let me go with the right. So this is fine. So now within the DFS method, first thing, let me go with the variable checkpoint. Yeah, checkpoint. Let me assign this one to history dot size actually. Yep. So it's as simple as that. Now we are done with this part. Why we have went with the checkpoint and we have assigned that one to the history dot size? We have to save the state before applying the changes for that reason. Next, let's move on with the for loop. For the for loop, I'll just go with the edge here, edge E. So this is fine. Edge E of segment edges. So this one edges not adds this time. Let me pass the index variable. So this is also fine. So we have already written the union method. So let's make use of it because we have to apply all the edges active in that particular segment. For that itself, we have made use of the DSU, and within that one, we have written the union method. So I'll just go with e dot u and e dot v respectively. U and v. We are making use of u and v itself, right? So we have applied all the edge active in that particular segment successfully. Now let's move on with a one more for loop because we have to apply all the updates as well, right? So again, let me copy the same thing. We are going with the this one update as well, right? For that also we have to write the code instead of edge. So let me go with the add here. So here also I have to make the change, I believe. So somewhere did I give edge? No, right? This one second. Did I give SEF ads or SEG ads here? One second. Hmm, where I have considered one second. EF ads. Okay, I have considered here. Let me change this one to SEG ads actually. Yeah. So now if somewhere we see the red color, if we get the error, we have to change actually. So here I have changed, I believe, segment. So this is the only place where we have made use of the variable segment addition or the segment, right? So this is fine within the update, I believe. Anyways, now let's move on with the further things. So I'll just go with the add. Add what it is saying. Required. So yeah, further we have to change, right? So I'll just go with the segment adds here. So this is fine. Let me remove this one of index. So this remains same. Instead of the union, so we have to go with the add value, right? Add value of this one. The same thing. Instead of u and v, we will be going with the this one node for this one as well. Yeah. So we have considered the variable actually a. So I'll just change this one from e to a actually for this one as well. So we have to go with the a dot node. Yeah. So this is fine. Add. Oh, I have to change this one as well. For the update, I'll just go with the a. So this is fine. We are done with the updation part as well. We have successfully applied all the updates. Now we have to consider the leaf node for the single query. If we have the single query, so I'll just go with L plus 1 if it is equal to R. In that case, so within the if condition, if type of this one, what do we call L, suppose if it is equivalent to 3, then I'll just go with int root equals, let me go with find of this one, a of L. Yeah, find of a of L. So this is fine. Next one is nothing but after finding the component, we have to store the answer. So I'll just go with the answer of L. Let me assign this one to the component sum of root. Yeah, component sum of root. So let me format the code so that the code looks good. I'll just come to the else part here. So I'll just go with the else. So first, let's calculate the mid. We have to split, right? First split or calculating the mid, then we have to consider left as well as the right side. So for calculating the mid, it will be left plus right by 2. I'll just go with left plus right, right shift 1. Again, this is fancy way of writing by 2. Yep. So then let's recurse for the left side. I'll just go with the DFS of index left shift 1. Yeah. And left as well as the mid, which is absolutely correct. For the right, I'll just go with DFS index left shift 1, right shift 1, sorry, logical or 1, then mid right. So which is absolutely correct. Let me format the code so that the code looks good. Now we have to undo the changes. For undoing the changes, we have to go with a rollback actually. Yeah, I'll just go with a rollback of, all we have to do is we have to pass the checkpoint. Yeah, so let me format the code so that the code looks good. Now we are done with this one. What do we call? DSU, we are done with the segment tree, we are done with the DFS, nothing but the divide and conquer as well. Now we are done with the main things. So we have to do certain things within the main method. Yeah. Accordingly with the question that they have asked. So certain input output changes and certain things that we have to do within the main method. So I'll do one thing. I'll just copy paste the entire main method and let me explain. So I'll be going with the fast scanner as well. So I'll just paste that one. You can just make use of any template. So for this, we need extreme optimization. So I'll just go with a this one, fast scanner. So I'll just paste that one as well. So I'll be going with a custom fast scanner actually for the input output part. I'll be copy pasting that one as well. I'll explain this one, whatever we write in the main method. And for the fast scanner, you can just go with any template of your choice. Yeah, that's left to you, right? So just give me a second here. So let me do one thing. I'll just paste it over here, right? So this part, this is nothing but for the fast output, you can just make use of the any template of your choice. It doesn't matter, right? So I'm not going to explain this one. This is just purely related with the input output only. If you don't want to go with this, if you just want to go with the buffer data as well as the print writer, that also works. Yeah. So I'm not going to explain this. This is purely related to the input output part. Yeah. Let's discuss the main method actually, whatever we have written in the main method. Yeah, it will be mostly related to the input output part and certain methods that will be making use of just for the printing certain things and other stuff, right? So within the main method. So let me explain this one. Fast scanner again. So as I've said, it is completely related to the input output part. I have made use of it here. I have called the fast scanner method here, right? So this is fine. Next, what we are doing, so we have to read the number of nodes and we have to read the number of queries. Yeah, in the input, if you check, so I'll just open the Chrome. So in the input, we have to read the number of nodes and we have to read the number of queries actually. So for that, I have just made use of n as well as the q. We are reading this one, right? Input part basically. This one we are reading actually based on the input that I have given. So that's what I have mentioned here. Fs is nothing but this one, fast scanner variable, right? Fs.nextInt. Next, let's move on with the initial. So this is nothing but the initial values that they have given, and we have to read the values that they have given in the input. For that, I have made use of the for loop. So this is fine. Next, type equals new int. So this is nothing but the query type, and a, b as well as the x is nothing but a is nothing but the parameter a, b is nothing but the parameter b, and x is nothing but the parameter x. So this is fine, I believe. Next, let's move on with the for loop. So within the for loop, we have to read the query type. For that, see here, t equals fs.nextInt. Next, let's move on with the if conditions that we have that we have written actually, if as well as the else. So here what we are doing, we have to read the vertex u as well as the vertex v. So this is nothing but we are reading vertex u as well as the vertex v. Next we have to read the node as well as we have to read the value, that we are doing within this if else if condition. Then we have to read the node for the query. So for that we have written within the else actually. So this is fine, I believe. Next, let me come out of this one entirely. Now let's move on with the further things. So segment edges and segment this one, what do we call, segment adds. So this is nothing but segment tree edges. So within the example, while discussing the algorithm as well as while discussing this problem itself during the approach, segment tree I haven't shown actually within the approach. During the algorithm I had shown you actually, yeah, the edges that needs removal, right? So and the range actually, so we had to remove 2 to 3. We had considered the range 2 to 2 as well as 3 to 3, if you remember the algorithm, that part. So we are considering the edges here, right? Nothing but segmentary edges. So here this is nothing but segmentary, this one updates, the update, if some update is needed actually, we have written, mm, yeah, for that also we have written the particular method, right? So we went with the variable segment adds. So we are going with the segment tree updates here. Next we are going with the initialization list twice actually, for the add as well as the update, same thing, segment edges as well as the this one, segment addition or update, however you call it, yeah. Initialize list, init list for both actually within the for loop. Now we have to handle the edge lifetimes, yeah. When I say we have to handle the edge lifetimes, so we have to map the edge as well as the start time. If you remember the algo, I have said you the same thing. So we will be considering hash map because we will be storing edge as the key and start time as the this one, what do we call, start time as the value basically within the hash map. So we had discussed this one earlier. You can check the video, right? You can just check the algorithm during the algorithm explanation actually in the algorithm. So I had said you the same thing, right? So we will be considering or we will be mapping the edge to the start time, right? So that's fine. We have done that. We will be doing that one, right, by making use of the hash map. So this is fine. Next, we have written the for loop. So we have to normalize the edge. So here I have made use of the if condition. So this is also fine. Next, we have to encode the edge. For encoding the edge, we have considered this part. Yeah. This one, left shift operator 32, whatever I have written, 0x this one. This is nothing but we are encoding the edge. You don't have to worry that much. And we have to store the start time. For storing the start time, we have made use of the put actually. Store the start time in the sense we have to update. So update. So that is provided by the put, by the hash map. We have made use of the put operation that is provided by the hash map. We are updating the t actually, starting time. Yep. So we are storing the start time in simple terms. Now within the else if, what we are doing, so we have to normalize. So within the if condition, what we are doing, we are just normalizing. Then we have to similar to this one, we have to encode again. We are doing the same thing here as well. And we have to get the start time. For getting the start time, I have just made use of the remove of key, remove operation that is provided by the hash map basically. After getting the start time, all we are doing is we are adding the interval. We have to add the interval, right? So that one will be done by this step actually. Through this step, we are just adding the interval, sorry. Yeah. Now let's move on with the further steps actually. This for loop. So within this particular for loop, all we have to do is we have to decode the u and we have to decode v. Decode u and v in the sense, yeah, we have to decode the vertex u as well as we have to decode the vertex v. That's what we are doing within the line number 234 and 235. This is fine, I believe. Next, after decoding the u and v respectively, if we have to check whether uh, the edges are still active till the end. Yep, that's what we are doing with the help of this particular method. Yep, add edge actually. Yep, so this is fine. Now we have to handle add queries as well. Within the input, they have given us queries actually, right? Queries, add queries. We can call that one as add queries or queries. So this is fine. Yep. If they have given something within the 0, we were adding. If they have given something with the 1, actually, we were deleting. If they have not given anything, in that case, we were going with a query. We were considering the query according to the input. So let's handle this one. Within the handle add queries, what we are doing, let me tell you this one. within the handle add queries, we are going with the initial values. Yeah, we are just going with the initial values. So we have called add update method here and passing the parameters, right? So that is the reason we are just going with the initial value. So that is the reason I have went with new add of I, initial of I. So this is fine. Next, within the for loop, we have to add the updates as well. Within the for loop, we have to add the updates as well. For that, this one, we have went with the add update here within this particular for loop. Yeah, again, the same parameters, and we are going with the add here, right? So this is fine. Finally, this is kind of solved. The main thing, and whatever the thing that we have to display, we are doing from here, right? So I have called the init DSU, nothing but we are initializing the DSU. We have to initialize the DSU. So what we are doing here, I have called the init DSU. So this is fine. Next, I have assigned the answer variable to allocate the answer array. So here I have assigned the answer to new long of nothing but Q here, this one. Where did it go? So this one, this part. So this is fine. Next, we are going with the DFS. We have passed the this one parameter values. We are just processing the segment tree here. So DSO is nothing but DFS is nothing but we are that is used to process the segment tree. It uses the divide and conquer technique. Yeah. So here what we have done, sorry, not this part actually, yes, DFS, we are just processing the segment tree. So we have provided the initial values here. So you can clearly see index, we have set this one to 1, right? We have set this one to 0 and Q. So this is fine. Next, finally, we have to display the output. Yeah, we have to display the output. See, we have made use of the string builder, right? So string builder, because we need extreme optimization here in this case. So we are going with a fast output. So I'm making use of the string builder here. Within the this one, what do we call? For loop. So we have to append the answer. So I've just went with the answer of I. So basically the answer that we get, that is stored in the answer variable, right? Answer variable, we are calling the answer and we have to append the answers. So we have to move to the next line for the second one, third one, fourth one. We have to display in the next line, right? For that one, we have appended /n. Yep. So this is fine. Finally, for printing the output, that will be stored in the string SB variable. This one, string builder variable SB, right? So we are just calling SB within the print. So system out print. So this is fine. So as we are not making use of the this one buffer reader and the print writer, we are just going with a custom fast scanner here. I'll not be explaining this. You can just go with any template of your choice, fast template of your choice for the fast input output. Yeah, it's your choice. You can just go with a buffer reader and the this one print writer as well. Just buffer reader and print writer, that also works. Yep. So this is fine, I believe. So this is it for the coding part. Yep. So this is it for the coding part. Let's do one thing. Let me do one thing. Yeah, if everything goes well, this is huge, man. I hope whatever we have written is completely correct, actually. So if something goes wrong, then we have to debug. If everything goes well, let's check for the output. So let me run the code. So yeah, this is asking for the input. So we do not have any errors, I believe, for now. Let's see. Let's check actually. I'll just open the Chrome. So let me completely copy the input part. So from the question I'm copying the same input. You can clearly see here, right? So let me copy from here to here. So this one is fine, I believe. Let me copy this one. Let me open the IntelliJ IDEA. Let me paste this one over here. Now let me hit the enter. Right. So we are getting 10, 10, 5, 6, 5, 11. So this is absolutely wrong, right? Let's see what we have done wrong actually. Let's check. Okay. So what mistake I have done here is within the DFS method. So let me come to the DFS method. Yeah. So this is DFS method. This is fine. Yeah. So then segment tree. This is also fine. Add adjacent rating. Then we have come to this one. Divide and conquer method, right? So nothing but DFS. So here, see. So yeah, see here within this part actually, we are updating right here, right? So instead of adding the value delta, what I'm doing, I'm adding the node actually, a dot node twice. So I had copied the same thing actually from here, I believe. I forgot to somewhere, had copied, I forgot to change, I believe. So here, this one, what I'll do, I'll just go with a delta. So this one I copied, I believe. So node I had this one copied twice instead of the delta. So now we have to get the correct output. This is the only change that is required, I believe. I don't know. Let's check. So let me do one thing. Let me run this one again. So this is asking for the input. So I'll just open the Chrome. So let me copy this one again actually. 1 second. Yeah. So let me copy this one. Open the IntelliJ. Let me paste this one and let me hit the enter. Yeah. Now we can clearly see we are getting uh 5 ones, 100, double one, double one, double zero, double one, double one, double zero, and finally triple one, triple one. As per the output that we had discussed actually, as per the output that we got, the same input we had considered within the approach as well initially, where we discussed with the graph and other stuff by considering the same input, right? So we are getting the correct output now. Yep. So we are getting the correct output. That was the only mistake actually. What was the mistake mainly? Instead of the node, we had to go with a delta, right? Um, yep. Instead of adding the node, we have to this one. We have to go with the value delta there. So that was the mistake. Anyways, now let me minimize this. So now I'll just copy the entire code. Yeah, whatever I have written. So let me open the Chrome. So there is an option here. So at the end, so TLE knockout, right? So meaning we have to submit the solution over here. I have already selected the language Java. So let me paste the entire code here, right? So before submitting this one, let me make some changes here. So this one, let me remove this. It is not required. And in the TLE, so in the library checker, actually, we can just go with the same name, I believe. It doesn't matter, I believe. And also we can go with a public class, actually. Let's see. I'll just go with the main. So this is fine. So if I remove public, let it be. So if I let me submit this one, if we get the error, we can just remove the public as well. Yeah. So let me hit the submit. So let's wait for some time. Wait for some time. Status you can clearly see here. It is taking time actually. Yeah. We have 19 test cases. Let's see. So you can clearly see the status we got here is AC and along with the green tick bar, nothing but accepted, right? So whatever the code that we have written works absolutely correct for all the test cases. Test cases you can clearly see here, right? So this is having actually the UI is intensely good for this within the library checker actually. I love the UI. Anyways, so here the test cases, this one example, you can see all the test cases here. You can just this one elaborate this one and you can just collapse this one as well. See here standard error. So okay, 6 tokens. We are shown all the test cases actually. See here, all the test cases are getting passed and our code is here, right? The entire code, whatever we have written, the entire code is here actually. And again, I'm telling, so this part you don't have to worry. This one fast scanner, I didn't explain. So you can just go with any template of your choice. And as I've said, you can just go with a buffer reader and the print writer as well, right? So the only thing that you have to remember is whenever we are this one implementing the offline dynamic connectivity algorithm, so we have to go with, if we are going with a pure implementation of it, we have to go with a segment tree for the offline processing, and we have to go with the DSU with the rollback because we have to, if we have to perform the delete operation, delete is not supported by just DSU, right? So we have to go with a rollback. Yep, for that we will be going with a that for that purpose itself we have went with a DSU with a rollback. Yep, so that's fine, I believe. Yep, DSU with the rollback for the deletion, and this one, what do we call, uh DSU with the rollback we have went with, then segment tree for the offline processing, and divide and conquer via DFS method, that also we have went with, and other stuff that's related to the input output. And this one, what are the things, yeah, how we have to update, how we have to this one display the output. Yeah, those are all the things that we have written within the main method actually. Yep. And again, fast scanner, you can just make use of the this one, what do we call, custom template for the input output, or you can just go with any this one, what do we call, just buffer reader and the print writer by importing the input output package. Yep, so that also you can do, it doesn't matter. Yep, so this is it for the code. Yep, so whatever the code that we have written works absolutely correct as we are getting the AC here, nothing but accepted. Yep, so this is fine. Let's do one thing. As we are done with the coding part and as we are getting the this one, what do we call a desired output, let's move on with the final part, nothing but discussing the let's discuss the complexities for the code that we have written. Let's do that quickly. So let's move on with the complexities part here. Let me open this one. Give me a second. So what will be the time complexity here? The time complexity would lead to big O of n plus q log n. Yeah, the time complexity would lead to big O of n plus q. Let me go with one more parenthesis here. So this is nothing but logarithmic q. So why it is big O of n plus q logarithmic q? See, each edge or update is inserted into the segment tree, nothing but logarithmic q, right? So logarithmic q. We are speaking of the update actually. So each edge or the update is inserted into the segment tree, nothing but log q nodes and the DSU operations. DSU operations, so this is update, this one that's related to the segment tree. Yeah, and each this one DSU operations, nothing but union, add, and rollback. These three operations we are performing or considering actually, they are processed during the DFS traversal. So that would lead to big of n plus q log q time complexity as whole. So overall time complexity would lead to big O of n plus q log q. And what would be the space complexity here? Space complexity would lead to big O of n plus q log q as well. Big O of n plus q log q. So this one will be, yeah, big O of n plus q log q. So why it is big O of n plus q log q? So we are making use of the DSU arrays that take big of n, and we are making use of the segment tree as well as stored operations, right? Stored operations in the sense edges, updates, history, these three things we are making use of that take big of q log q. So overall space complexity would lead to big of n plus q log q. So right, so this is it for the time as well as the space complexity. So the overall time complexity as well as the space complexity for the code that we have written would lead to big of n plus q log q, and space complexity would lead to big of n plus q log q as well. So this is it for the complexities part. Yeah, it's as simple as that. Now we are done with the complexities part as well, and we are done with this particular problem as well. We have successfully implemented offline dynamic connectivity algorithm within this problem. I hope the algorithm offline dynamic connectivity is completely clear. Let me summarize. It just makes use of the segment tree for the offline processing, as the name itself indicates, that offline dynamic connectivity. Yeah, it makes use of the dynamic what do we call, sorry, segment tree for the offline processing and divide and conquer, and it uses DSU with the rollback. Again, why DSU with the rollback? So the traditional DSU cannot we cannot go with the delete operations, or it cannot perform the delete operation. So we have to go with the DSU with the rollback. So that is the reason we'll be going with the DSU with the rollback, not just traditional DSU, right? So these three things we have to know for the implementation of offline dynamic connectivity algorithm. Again, I'm stressing on this. If you don't know segment tree, if you don't know this one, what do we call, DSU with a rollback. If you don't know DSU itself, rollback is just that it's a kind of this one. You are adding certain things. That's it. Yep. You are tweaking certain things, right? For the deletion operation, you are tweaking certain things within the rollback, right? So you have to roll back the changes at the end. For that reason, we'll be making use of the rollback method. You have to know the DFS. Sorry, DSU actually. DSU. For if you don't know the DSU itself, and if you don't know the segment tree, and if you don't know the divide and conquer, these three things, so these are explained within the 150 algorithms playlist. You can just check that playlist, and later you can come back here and this one, just watch the video, or else you'll not understand anything. So you have to blindly implement. Yeah, you have to blindly implement. If you don't know DSU and if you don't know segment tree, it is impossible to implement, or it is impossible to solve this particular problem. Yeah, I insist you to go through that this one algorithm, and then you can come back here, and then you can just watch the video, or you can just follow along if you are completely following along actually, along with the code actually. So this is fine, I believe. We are done with the yeah, we are done with this part. Yep. So yep. Next we are left with only one algorithm within this particular playlist actually, dynamic graph algorithms, complex dynamic graph algorithms. That is nothing but DSU with this one. What do we call? DSU with a rollback. Yeah. we have implemented the DSU with a rollback. So for that, that completely comes under this one. What do we call? Dynamic graph algorithms playlist itself. So where we'll be only seeing the DSU with a rollback next actually algorithm, as well as we'll be implementing the same thing with an one problem. Yep, that's easy. DSU, just DSU with the rollback is completely easy. We do not have to worry. Here, basically offline dynamic connectivity, it consists of the three algorithms basically. DFS you have to know, that's different, and within the DFS we are going with a this one divide and conquer technique, again segment tree, as well as the what do we call the final one that we have implemented just now, DSO with a rollback. Yep, these three things we have to know, and related to the input output, accordingly with the input that they have given, we have to make some changes within the main method. That's how I follow. If you want to write everything within the main method itself, you can go with that itself. And I have made use of, again, I'm saying fast scanner is the custom input output part. You can just go with any template of your choice, or you can just go with the buffer reader and the print writer by this one importing the input output. That also you can do. That works as well. Yep. So this is it for this particular algorithm, this one offline dynamic connectivity algorithm. Yep. So, and as I've said, next we will be discussing on the topic DSU with the rollback, right? So that's one of the important algorithms as well. For now, this is it. Thanks for watching, guys.